Hello, hello! Welcome back to another wonderful day of pre-calculus. Today we will be covering factoring polynomials and all of the various methods that entails. So put away those distractions, pull out those notes, and here we go. Alright, so to start off, we're going to start with the very most basic of all factoring, and that is the greatest common factor. This is the thing that you always check for first. So the first thing you do when you're trying to factor things out with the greatest common factor is you list the factors in each term, find out what factors are in common to every term, and then you pull out the common factors, leaving what's behind. So we've got our wonderful example here. We've got 24y to the fourth minus 54y cubed. And so to get started, let's start talking through that. So when we're looking for the factors of things, there's a couple different ways that we do that. One of them is to do one of these good old prime factorization trees where you're like, okay, what two things multiply to make 24? That'd be a 4 and a 6. Let's see, 4, that's a 2 and a 2. 6 is a 2 and a 3. So 24 is 2 times 2 times 2 times 3. And then we've got y to the 4. So 1, 2, 3, 4. Another method that we can use is called a factor ladder, where we start with 54, and you always start with the smallest prime that will go into that. So the smallest prime that is even, so we can divide it by 2. That'll give me 27. Not divisible by 2 because it's not even anymore, but it is divisible by 3. That will give me 9, and 9 is 3 times 3, and there we go. That's our prime factorization. We've run into a prime number at the bottom, so that's how we know we're done there. So 2 times 3 times 3 times 3, and then this one's y cubed. So 1, 2, 3. The next piece of our puzzle is we go looking for what things are in common. So I have a 2 and a 2. So my GCF is going to include a 2. And this guy has a second 2, but this other guy doesn't have any more 2s. So we're going to skip over the 2s. This guy has a 3. So does this one. And then no more 3s there. So even though this other guy has 3s, we don't care about those. And then how many y's? Let's see, that guy has 4 y's, but this guy has 1, 2, 3. So that's what they have in common. 1, 2, 3. So multiplying that all together, we end up with 6y cubed. So our GCF is 6y cubed. And then we've pulled out our common terms, but what's left for each of these guys? So the what's left is we've got a 2, and a y. So 2 times y, that will give me 4y, is what's left here. We keep our sign, so that's going to be a minus. And then over here on this other guy, we had 2 3s. 3 times 3, well, that is equal to 9. And that's 9. And there we go. That is all of the work that goes into pulling out the greatest common factor when you are factoring something. If you can look at that and you just know what it is, that's perfectly fine. I'm trying to show all of the steps because, well, it's the beginning of the year and sometimes people's brains are a little fuzzy. Alrighty. It's always a good idea to check to make sure that there's no common factors between things if you're just trying to eyeball it, instead of going through this precise method, to make sure that you didn't skip one of your GCFs. Alright, moving on to the next one. Our biggest column is the patterns. So what are the different patterns that we can use when we are talking about factoring? So our first pattern is a difference of squares. And the difference of squares is where we have something squared minus something else squared. We can factor that into a plus b in one set of parentheses, and then in the other set of parentheses, a minus b. So perfect square numbers, things to look out for. You're like, I might have a perfect square here, as you only have 2 terms that you're trying to factor, and you see a 1, a 4, a 9, a 16, 25, 36, 49, 64, 81, 100, on and on and on, 121, 144, 169, so on and so forth. So we're looking for perfect squares numbers. We're also looking for exponents that are even, because that also lets us know that we have a perfect square of some sort. So what we do first when we're looking for perfect square when we're looking at a difference of squares is we go, okay, well, I've got 2 terms, they're being subtracted, so can I rewrite this as something being squared? Well, 1 is 1 squared, so I can leave the 1 on the top. 144, if I took the square root of 144, that would give me 12. All right, so that's my first one. And then for these guys, if I was wanting, we're kind of doing the power rule of exponents, but backwards. I want to put a 2 on the outside. So usually when we're using the power rule, we would have something in here, and we would have to multiply this exponent times 2 to get 6. So basically we're going backwards, so we're dividing instead of multiplying. So it would be r cubed and s squared, because we started with a 4 and a 6, and we're dividing those by 2 because we're wanting to pull the 2 out, if that kind of sort of makes sense. All right, so now I have something squared minus something else squared. Now I can put up my little pattern for my perfect square trinomial, or my difference of squares. Sorry, we're going to get to perfect square trinomial. So we put the first thing, 1 over 12, 1 over 12. We put the second thing, so that's r cubed s squared, r cubed s squared, and for one of them we add, and for the other one we subtract, and that's it. That's what we do. So that's how we do a difference of squares. Now sometimes when we see two deuters, we're like, oh hey, yeah, let's go ahead and do the difference of squares. So we're like, okay, well 16, this would be 4x squared that's being squared, this is 1 that's being squared, but oh wait a second, that's a plus, not a minus. As soon as you have that plus sign in between the two things, that means that this is prime. We cannot factor it. This is basically like a prime number, like 3 or 5 or 7. There's no dividing it down into smaller individual pieces. So we just say prime, we circle that, we move on with our life. And that one's done. All right, our next pattern is the sum of cubes. Now perfect cubes are 1, 8, 27 is 3 cubed, 64, 125, 216, 343, 512, 729, and 1000. So our sum of cubes says if we have something cubed plus something else cubed, we can still factor that out into two things. It turns into a binomial times a trinomial instead of a binomial like the one above did. So we're going to pull these things apart and we're going to go looking for our stuff. So our process is kind of the same as for the difference of squares. We're going to go, okay, well what do I cube to make this first term? So we have 8f cubed. I want to cube something, and then I want to cube something else, and I'm going to end up with these things. Okay, so 8 is the second on my list, so this guy's really 2 cubed, so that would be a 2, and I'm going f cubed, so that would be 2f. So 2f times 2f times 2f would give me 8f cubed. Yes. All right, 729 is out here. That's our 9. So this is 9m. I don't want just m to the 1 because that would give me an m cubed. And I want an m to the 6 as my final thing. So I'm going to write m. Oh, no, 6 cubed would be 18. I want this to be 2. There we go. So now I have something cubed plus something else cubed. So this turns into my me. This is my x. And this is my y. We'll do that. Yeah, we'll do that in pink. And so everywhere we see an x, we're going to write that 2f nonsense. And then everywhere we see a y, we're going to write it in with the 9m squared. So let's actually process that out. So we have 2f. All right, I'm going to kind of fill in the blanks. Floop plus floop floop something squared minus stuff plus something squared. And then we'll have to clean things up and kind of organize the inside of that parentheses there for a second. But anyway, going back to putting the 2f's. So then we put a 2f here and a 2f here. And then we add in 9m squareds, 9m squareds, 9m squared. All right, so now we have to kind of finish this up, bring it all home. We're going to leave the first set of parentheses alone, unless you can combine like terms, which you shouldn't be able to, because otherwise you would have just combined like terms at the beginning. 2f squared, that's going to give me 4f squared, minus 2 times 9 is 18, f m squared. For this, we usually list things alphabetically when we have multiple letters or variables that we're playing with. Plus 81 m to the 4th. Bada bing, bada boom. And you can always plug it into Desmos or some other graphing calculator and kind of multiply it out, make sure that you end up back where you started from. All right, our next pattern is called difference of cubes. It is very, very similar to the sum of cubes. So real quick, I want to point out what those differences are. Up here with a sum of cubes, we're starting with a plus sign, and down here we're starting with a subtraction sign. So the two differences is the first two signs. If you have a sum of cubes, you always have a sum first and then a subtraction. If you have a difference of cubes, you have a subtraction inside the binomial and then a plus plus. They always end with plus y squared. So that's kind of a nice little thing that they do. All right, so going back here for my cubing patterns. 125, that's really 5 cubed. And then, let's see what's being cubed here. A v, not squared, cubed. And 2 cubed gives me 8. So those are my x and my y. So I'm going to put in all of my sets of things. I'm going to do my pattern. So this with a minus, and this, something squared, plus stuff, plus something else squared. Close. All right, so my first guy is 5, 5, 5. And then my second guy is 2v, 2v, 2v. And then I can bring this all together, bippity boppity boo, and I've got 5 minus 2v in parentheses, 25 plus 10v plus 4v squared. All right, and that's the difference of cubes. Now we move on to perfect square trinomials. Yay, perfect square trinomials. Okay, so this one has two different potential forms. You can have a squared plus 2ab plus b squared equals a plus b squared. Or you have a squared minus 2ab plus b squared, and you end up with a minus b squared. So notice that they always end in the plus b squared, so you always have a plus at the end there. And so you got something squared, you got a 2 in there, and all that other fun stuff. So the trick for these guys, typically speaking, is you find out, so process, I forgot to write this down. All right, so my process is first I find out, okay, what is A and what is B? What is A? What is B? I use first term, and then I use the third term. And does 2AB equal the second term? That's my little guess and check, my little process that I use here. So my first term is x squared, so A equals x. And then my second term, or my third term, is 3 squared, so B equals 3. And then we've got 2 times A, sorry, my pen's not cooperating, my little duties up here aren't cooperating with me. 2 times x times 3, so that would give me 6x for second term. And 6x is the second term. So notice I'm not paying attention to the plus or the minus part when I'm doing my check for my verify. That'll come in here at the end. So that does, everything checks out. So we're going to have that whole thing. We're going to take this symbol that's in front of the 2AB, and that's the symbol that goes in the middle there. And then we're going to put in our A, we're going to put in our B, and then we're going to square the whole thing. Bada bing, bada boom, we're done. All right, so let's do this other one just for kicks and giggles and smithereens. So we've got 2x squared, so A equals 2x. And then we have 5 squared, so B equals 5. And 2 times 2x times 5. That all together, 2 times 2 is 4, 4 times 5 is 20x. And that is my second term, so we're good to go. And setting everything up, we have this. We keep this symbol, so there's a plus, it's going to be squared. My A was 2x, and my B was 5. Boom! Ah. All right, we're done with all of our patterns. Just going to check, make sure there isn't another one. Yes, okay, good. Did all the patterns, yeah. All right, next up we have factor by grouping. Okay, so factor by grouping only works if you have an even number of terms. If you have 3 terms, no dice. You're going to put parentheses around the first, around pairs of terms, creating groups, hence the factor by grouping. Make sure that you pull subtraction signs into the groups. Just add pull subtraction signs into groups, just put them in between, it's fine. And then find the GCF for each group and factor it out of the groups. And then hopefully, if your groups are all identical, you can go ahead and move on, finish factoring. All right, let's do this. All right, we have factor by grouping, and we're just going to do this, and we're going to put a plus in between. That's what I mean by just add in between. We're just going to put a plus sign right there. Hi.
Can I help you erase?
I'm not ready to erase right now.
Okay.
But when I'm ready to erase, you can definitely help me erase.
Okay.
Can you say hi to the students?
Hi.
Oh, they saw your hand. Can you come over here?
Hi.
There you go. Thank you so much.
Did I see my hand?
They did see your hand.
But what are our students anyway?
Well, this is a recording. My students aren't actually here. They're going to watch this later.
Why?
Because that's how it works. All right, now we're going to do factor by grouping, or we're going to pull out the GCF. So what goes into 6 and into 9? That would be a 3. And we have r squared, so that leaves us with 2r minus 3. And then over here, what goes into this, a negative 5. So you can always do, pull out a negative, just remember to change the signs on everybody that's left. So that positive 15 becomes negative 15. Oh, I forgot the 2. And then we check. Is this thing inside the parentheses the same as that thing inside the parentheses? 2r minus 3, 2r minus 3, they're both the same. So we're now going to basically treat that like our new GCF, and we're going to factor out 2r minus 3. And that's going to leave us with a first term of 3r squared and a second term of minus 5.
Oh, can I also have you switch colors?
The colors are very far away from where we're sitting, so not really, unfortunately. Plus. So we got z cubed plus 7z squared. Z squared.
I wanted to erase that.
Oh, sorry. I was going too fast. Next time I need something to erase, I will. Alright, so what can we factor out of this first thing? That would be a z squared. And that leaves us with z plus 7. And over here, we've gone pulled out negative 5. So that leaves us with z plus 6. Is this the same as that? Z plus 7 and z plus 6. Is that the same thing?
Yeah.
Really? Plus 7 and plus 6?
No.
No. So we're going to write that this is prime, and we can't factor it. We're done. Because we can't do anything else with that. All right, let me check my notes. I think we're done with this column, and we get to move over. Yeah. All righty. Oh, now we get to factor quadratic trinomial patterns. There's 2 of these patterns. If you haven't stood up and stretched real quick, that's a good time to do it. All right, Keelan, I need to focus on what I'm doing. All right, so there's a lot of different ways that people do these things. I'm going to show you my method, and that's just what we're going to do.
Oh, do you see that the race thing?
I'm not going to erase things, Keelan. Can you go down and say hi to Dad for me?
Do you see that?
Keelan, I need to focus on this. Can you go say hi to Dad for me? Give him a hug. Thank you. Alrighty, so what I do, so we're leading coefficient of 1. So we're looking for a pair of numbers whose product is the constant. Remember, the constant is the one without an x or without a variable, and whose sum is the middle or linear term. We're going to multiply to make the number by itself, the no variable, and add to make the number with the variable with the lower exponent. So that's kind of what we're looking for. We're going to replace the middle term with that pair of numbers, and then we're going to use factor by grouping. This is the process that I typically use. There's 150 gazillion other different ways to do this. So here's my constant, so negative 30. And I'm looking for numbers that multiply to make negative 30, and that are going to add up to negative 13. So I'm going to start listing off numbers. Negative 1, positive 30, that gives me positive 29. That's not going to work. Okay, it looks like with a negative number, I want the larger number to be negative. Larger number, negative. So I should have done 1 and negative 30, but that will give me a negative 29. 2 and negative 15, that will give me negative 13. Hey, there's my pair of numbers. All right, so what we're going to do is we're going to replace the middle term. So we got m squared and minus 30. And in the middle, we're going to write plus 2m minus 15m. And it doesn't matter what order you write those in. That's just what you do. And now we're going to trigger factor by grouping. Make sure to put a plus sign in there. So m squared plus 2m plus negative 15m minus 30. It's going to be a little while before I need to erase anything, Keelan.
Why?
Because I'm blitzing. I'm going zoomy fast, and I'm not making any mistakes so far. All right, and then doing my check, that is the same as this. And we've got m minus 15 and m plus 2. Oh no, I need to do this next one. Arg! We're getting long, but that's okay. We need to do this because this is a type of factoring you're going to see a lot in this class where it's a quadratic, but it doesn't look exactly precisely like a quadratic. So, go down and say hi to Dad. And please shut the door on your way out. Off you go, kiddo. And this is where the whole thing about multiplying the number.
Mom.
Keelan.
I'm playing the fish game, but I'm having a little bit of trouble looking at how the fish is going.
Well, you'll have to talk to Dad about that. You'll just have to keep practicing. What number when there's no number? It's a 1. So, I need to finish this lesson for my students.
But I want the wrong rates.
So this is positive. So I want the larger number positive. And you can have this TV back after I get done with this recording.
What do you say?
After I get done with this, you can watch YouTube and stuff on this. But I have to get done with this first. Positive 8. He usually watches TV on here. And there's my positive 1 right there. Thank you. Okay, so sorry about writing while talking with other things. So we're trying to multiply to negative 20, adds up to positive 1, it's 5 and negative 4. Going to replace the middle term. So we have x to the 4th plus 5x squared minus 4x squared minus 20. It's very important that you keep the x squared because that's what we started with. And we're still going to go through factor by grouping. Same process as before. We're going to parenthesis with plus sign. So x to the 4th plus 5x squared plus negative 4x minus 20. I do sometimes make mistakes. Right there. Anyway, there we go. And now we're going to go looking for our GCF. So x squared. This would leave x squared plus 5. And then this is minus 4. And this would be x squared plus 5. Are those things the same? Yes, they are. So that leaves me with x squared plus 5. X squared minus 4. But I'm not done. Whenever you have something where there's extra things going on with your quadratic, you always need to check and ask yourself, can I factor this again? This is a sum of, it's a binomial, it's got a plus sign, so no. But this is a binomial with a subtraction sign, so it might be a difference of squares. In this case, it actually is. So my final answer is actually, this is x squared minus 2 squared. So this is x plus 2, x minus 2, and there's our final answer for that guy. Oh my goodness, this is going. It's going. Okay, what happens when the coefficient is not 1? There's two methods here. Our traditional method is to multiply the leading coefficient and the constant, find a pair of numbers whose product is your new number, and whose sum is the middle term. Kind of exactly what we did up above, where we take this number out here, and we multiply that to get our number that goes here. So that's kind of the straightforward thing. The other method I've learned of recently is called slip and slide, where you slip the leading coefficient to the constant by multiplying. Leading coefficient is now 1, and you just follow the process that you had up there. Factors if the leading coefficient is 1. At the end, put the original leading coefficient under the numbers as a denominator and simplify your fractions. Slide any denominators out to the front of the x in that particular group. So, let's see. I'm trying to make sure. All right. Here we go. And then there's also some things that people do with like this crisscross method. So we're going to try and like abbreviate this down as much as we possibly can. So the first thing I'm going to do is our traditional method. So we're going to take, I'm going to take this guy and this guy. We're going to multiply those two together. 2 times negative 17, which gives me negative 34. And we're going to, 17. 7. I was like, what's going on here? That number's way too big. All right, and there's also this x method where we put the negative 14 up here, and we take this guy over here, and we put him down here, and you kind of put numbers in these spots until you find the ones that work. We're actually looking for negative 14 and a positive 1. We're going to do our substitution, 2d squared minus 14d plus 1d minus 7. We're going to do factor by grouping, swoopity swap, swoopity swap. And I can pull a 2d out of here, which leaves me with d minus 7. And d and 7 are mutually prime. There's nothing that they have in common. So I'm going to pull out a 1, because I want to put some number out in front there. Then my check, as long as I've got some number out there, because otherwise it's easy to think that, oh, there's nothing I can do. There's always something you can do. There's always a 1. There's always a 0. There's always some number there that we just haven't written in. And bippity-bop, there we go. All right, so that was that one. Now we're going to do the slip and slide on this next one. Yeah. And I think that's where we're going to stop. So this is method 2. And what we do is we do the same thing. We're just going to multiply this over there. So we have g squared minus 21g plus 900. And I want something that multiplies to 900. But then adds to negative 21. So let's see. I know that's negative 16 and negative 15, just because of my notes over here. So g squared minus 6g, g plus, or actually yeah, plus negative 15g plus 900. And we pull out a g, we have g minus 6. And we pull out a negative 15, and we end up with g minus 6. And we have g minus 15, g minus 6. Bada bing, bada boom. And this is 27 minutes long. Oh my goodness, way too long. And just for your reference, this turns into a perfect square trinomial. Fun fact, this guy turns into 4w squared plus 5 squared. See if you can figure out how. All right, that's it for today. Oh, it's not. Frickadoodle goodness. I'm just going to talk through this. I'm not actually going to do any of these because we are at 28 minutes long. So we're going to bring it all together by factoring completely. Always look for GCF first. And then pick a method based on the number of terms. If you have 2 terms, you're looking at patterns, either difference of squares, sum of cubes, or difference of cubes. If you have a quadratic trinomial, you're going to be using, what are the quadratic trinomial patterns? Remember that you have blah, 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 and plus blah, 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 plus yada, yada. This guy is always a constant. This guy is going to have something to a power, and this is going to have something to 2 times that power. So it might be x to the 4th x squared, it might be sine to the 6th sine cubed, anything along those lines, but that's kind of your quadratic pattern that you're looking for. And then you also have, if you have 4 terms or some other even number, you're looking for factoring by grouping. Just real quick, how this guy would end up looking, you'd end up pulling out a k, and then you'd have j squared, and it looks like, let's see, adds to 3, multiplies to negative 28, positive 7, negative 4, but that's a difference of squares, so j plus 2, j minus 2. Always look for a difference of squares. They're always lurking. All right, and that's how that one would go. That's a factor by grouping, and this is probably a difference of cubes. Or squares. No, cubes. 6 is not a well, I don't know. All right, so warning, we never stop factoring, ever, 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 ever for the rest of this class period, the rest of this year, for this term, for this class. We never stop factoring for the rest of your mathematical careers. So make sure you have a solid and firm grasp of all of this content. Our next video is going to be rational expression skills. Let me know if you have any questions, concerns, comments, queries, and happy mathing!